All right. So, really, we're going to focus on triangles once we get past the quiz. But let's just talk in general when we have congruent polygons. Okay? Congruent polygons mean that all parts of one polygon are congruent to the corresponding parts of another. Okay? All parts of one polygon are congruent to the corresponding parts of another. So if you see down below here, okay, we have two triangles. And do you notice how all three sides are marked as congruent to each other and all three angles are marked as congruent to each other? Okay? Those are congruent polygons, more specifically congruent triangles, because all parts are congruent to the corresponding parts of another. Okay? When I say corresponding parts, okay, I just mean we have matching parts. Okay? So down below, like this picture right here, angle A and angle D, those are corresponding parts because they're in the same place of the two different triangles. And if we have congruent, it's a D, it's definitely a D. If we have congruent figures, then those corresponding parts would have to be congruent. Okay. Okay, somehow in this picture down here, my Y didn't print, and I don't know why. You saw that one coming. Okay, will you draw on the Y, please? The Y.
I think you got cut off with the key.
Probably. Okay. All right. So we have two different quadrilaterals. Okay. Let's match up all the corresponding pieces. If I write side AB, I'm going to write the segment AB. Which side corresponds with AB? Thank you, Philly, for saying WX. Okay. So that's a great question. So yes, these two are in the same space, right? But do you notice how A has the one swoop? So if I say AB, then I have to start here, WX. Okay? They do have to be in the correct order. Okay? So if I call our next segment BC, what is BC congruent to? XY.
You're welcome.
What I would like you to do is finish the next two statements. I'm going to write CD and AD, and I want you to match up who they belong with. Philip, what do we put congruent to CD?
YZ.
Okay. Lincoln, what do we put congruent to AD? Okay. And then our angles are a little bit easier to name because we just have to look at one letter at a time, right? Angle A is congruent to angle W. Angle B is congruent to angle X. Angle C is congruent to angle, what?
No, why? I meant why.
And angle D is congruent to angle. There we go. We got it. Okay, so our congruency statement, okay, we have polygon A, B, C, D. Now, normally, if it was a triangle, we just draw the triangle, okay? That's not a triangle. Is congruent to polygon. Which order would we have to put it in if I write A, B, C, D? It was very kind of them to put both of them in alphabetical order, wasn't it?
I know, that's how I just knew.
Hmm. Okay. On the next page, you'll notice that I have a triangle congruency statement, but there's no picture. We don't even need to draw the picture. Okay, this is what we can do, Josh Kane. If I know JK has to be a segment, right?
Yeah, I think you're putting on.
What?
Are you putting on the wrong side?
Yeah, that's the angles.
Why can't I do that? What is that? What is yours?
Keep you on your toes. Okay, so here's JK right here, right? Who does it match with in the statement?
You.
Okay. From the first triangle, what's another segment?
KL.
KL. And it corresponds with QR because they are in the same place.
So what would the third one be though?
What would the third one be?
JL.
JL is congruent to PR. Okay. Angles are the easier one. That's why we were doing them second. Angle J is congruent to angle P. Angle K is congruent to angle Q. And angle L is congruent to angle R. Okay. Please make sure you're putting the angle symbol. Oh. Triangle RSV is congruent to triangle TVS. It's an interesting choice of letters. RSV. Okay. Okay, so let's talk about finding X. Let's just talk about triangle RSV for a moment. What would the measure of angle R equal? I'm more looking for a number. If this is 90 degrees and this is 78, what's left over?
12
Oof.
degrees.
12 degrees. You know what? I'm going to change colors here.
That means I see what's 12 degrees.
Okay. So, what angle does R correspond with in the other triangle? Angle T. So, X equals 12. Okay. What's wrong? What are you missing, Josh?
I don't know, it's a good question.
He doesn't know what he's missing, but he's missing it. Okay. 2y minus 1. RS. What side does RS correspond with? Okay.
Oh, yeah.
So we know that we can put 2y minus 1 equal to 24.
Oh, that means 12.5.
Sure.
Booyah.
Okay, I'm going to give you a moment to solve for x and y in example 4, please.
That's like an hour. Oh.
Ella, what's the matter?
You want me to divide this by 3?
Why is there a
This
decimal?
by 3?
What?
Why'd you make a decimal?
Did I do something wrong?
So this degree measurement is angle D.
Why'd you add a decimal?
So is this this?
I'm done.
I remember.
Okay, Jacob, to find x, what do we need to do with 3x minus 10? Set it equal to 20. So what's x? Well, that was nice. Okay. Now, in this triangle, this is not my favorite problem because you don't even need to know the congruent relationship to find y. But what would this angle right here be if we do our 180 rule on that triangle? 53.13. So y, because we have vertical angles, is 53.13.
I don't like this.
Sorry.
Okay. So just kind of something to keep in mind that if two angles of one triangle are congruent to two angles of another triangle, we automatically know that the third angles have to be congruent to each other. Why?
Because this is the last thing.
We gotta equal 180. So if these two are the same and these two are the same, then the remainder to get to 180's gotta be the same. Okay? This is why I snipped it and you didn't have to write it down yourself. Okay? Now, we can, well, we have the same properties as we do for congruency and equality with segments and angles as we do with triangles. We have the reflexive property where a triangle is congruent to itself. We have the symmetric property where we can flip across the congruent sign, okay? And then we have the transitive property. I don't know if you'll ever have to use these, but they're there, okay?